I'm just going to adjust this. Gives it a good example of what the range of the accelerator control is. We're adjusting this signal for about 100% down to about the 10% range, and this shows what the range of the accelerator is. You'll notice how nice and even and smooth it is, and now it gives us a signal that converts the mechanical pedal, the driving pedal, gas pedal, to the injector. And this signal right here represents the on time of the injector. You'll notice that the on time can increase and decrease, and it's a very sharp, very nice pulse that controls the injectors. Now this is the this is the injector block right here. You'll see the injectors are sitting here and here, and this is what the injector looks like. And it sits right in here. And basically the gas will be coming into the device from this side, comes into here, to the injector down into the porting, or the input of the engine itself. If you'll notice, if you listen to the sound, you can hear the injector speed up. That's equivalent to running the car about 60 miles an hour right now. And we have plenty of dynamic range because we can adjust the ranges of that injector. These injectors are really going strong. Right here, if you put your finger on the end of it, you can feel the injectors. So they are in turn just running very, very fast right now. Is the accelerator control, and what this does is it converts the mechanical movement of the gas pedal to an electrical signal, which is brought into the system here, which controls the injection. So basically, as you would turn this device, which would be controlling the signals, you'll notice that it would also be controlling the injectors as the same function. So this device right here is the conversion between the gas pedal to an electrical signal which controls the inject time of the injectors. Alright, what I wanted to show you here was this is kind of a pre-engineering model that allows us to develop the electronics and the controls for the car, and then eventually all of this will be shrunken down into a very small package using LSI technology. Essentially what we're seeing on the packages here is we have a power supply unit here which actually regulates the battery voltage to a consistent level. This particular two modules here you see is associated with the distributor. You'll notice you can see the lights as they go around. Basically that is the distributor firing. This particular unit is set up for a 4-cylinder car but can also operate a 6-cylinder car. You'll notice that we have two select switches here. These switches right here allows us to switch between gasoline for an operating mode and then switch over to the water as an operating mode. This is so that we can test the differences between the two. These four modules right here basically are the injectors. They control the injector itself right here. We have both manual controls. All the switches in the down position is for manual control, and all the switches in the up position is for automatic control. This particular module right here is the accelerator module. This module controls all of the injectors simultaneously. This particular module right here is a gated module that controls the gated pulses and frequency to the water cells themselves. We can actually turn all the cells off and on by this switch, or go to a manual control where we can adjust the energy that the cell is using and its output by this control. This is the master generator. Everything in the circuitry basically is using digital technology. We do convert it to analog where we have to for the accelerator control. Over here we have a An alarm module. This module will give us an overspeed trip if the tach goes too high, if we have high pressure, low oil, or high temperature. And in some cases we put a jar switch on there so that if, like the Indy 500, that is a requirement. This module here is our tachometer module. Basically what happens here is if we increase our speed to a level, this run light will go out. You'll notice that you can see the lights flashing much, much faster. And we can get to a point, let me back it off here, I'll slow it back down, switch a range. Alright, now we're starting to increase our tach. Alright, let me take the inhibit off. We'll put it back into trip mode and you'll actually see it shut down. And there's where the engine would have gone into an overspeed condition and we shut the electronics off, therefore allowing the safe operation of the car. We have an alarm light on. We're sitting at a high tach. We had an overspeed trip. If I bring the system back down, I'll allow it to cut back in. We have all of these alarms set up to protect the unit.
John is taking the cell driver circuit, as you see right here, and we're going now to interface this with the voltage intensifier circuit. And basically what will happen is that a unipolar pulse train is now entered into the voltage intensifier circuit. And as this happens, this switching diode will now allow this coil to be energized, which is now hooked to the capacitor, which is the resonant cavity, and it forms a resonant charging choke. And basically what takes place is that this charging choke here will be energized, and it's a magnetic field now will restrict the amp flow, allow voltage to take over, and as a result we'll be able to produce a tremendous amount of energy, hydrogen gas from water on demand.
One of the pieces that we're retrofitting to the car is that I have my hand on right now is what we call the light gate, or it's a device that fits right on top of the distributor. Essentially what happens is we remove the distributor cap and we put this device in between, and essentially what it does is it takes the rotation of the engine, converts it to electrical signal so that we can control the injectors. This is a part of the light guide that fits onto the system, and we actually set it on the shaft, rotate it till we get the right calibration, and then put the distributor cap and its rotor back onto the system, and we're all set. This is a retrofit for converting.
Okay, now as you mentioned earlier, we'll take the light guide as you said here, all right? And then, boy, that went on pretty good, didn't it? And that shield will go on top, and then of course we'll insert the rotor cap. All right. And now we'll just go ahead and insert the distributor, see right here, okay? Now that'll be pretty good.
Where's your lockdowns at?
Now, what we're going to do now is that this is going to be replaced with this air gate, as you see right here. Right. Okay, so that's going to regulate. I better turn it up right, and that'll regulate our air going in.
Does this come off like this?
Yeah, it'll take off. Yeah, I won't do that. Now this will be, see, the air gate now will be hooked to the accelerator, the laser accelerator we have here. You know, that's hooking to your computer system.
All right. You're going to take this rod, you're going to hook it right up here, right?
Yeah, and that'll be for acceleration control. Okay. Now this is going to be our feedback, our exhaust feedback control, which sits right in here. And that'll regulate now the exhaust gases going back into the injectors, which in turn, here's our injectors. Okay. And so our exhaust gases are going to go back into the injector, and that'll regulate the burn rate of the hydrogen going into the engine, so we'll adjust the hydrogen burn rate to co-equal the gasoline as we've demonstrated.
Okay.
Previously.
Piece right here, then.
Yeah, this is where the regulator is going to be, the exhaust regulators. Now, this injector replaces this manifold as you see right here. Okay, and so it'll seat down in there, and then you'll have the ambient air go in to a gas, to the hydrogen gas guns, which now will go into the injector systems themselves.
Okay. All right. What we do is adjust the, we've got the injectors operating right here, and this is the inject time that we're seeing on the oscilloscope. And I can adjust the rate.
Ah, good. That means now we know, now the engine is specifically being set because of transmission to run around 3,000 RPM.
That's good. That's good.
Regardless of the year that we're going to be in.
Okay, that's
So
good. Now that's like the car running about 100 miles an hour. You'll notice here that this pulse here is the inject. This is the first injector, and then that's the second injector. And what you're seeing here in the sound that you're hearing is actually the injectors operating at that speed. Now if you go to about 3,000 RPM, I expect it to be something like that.
Okay. So the laser distributor now is going to be triggering this.
That's right.
They're going to be triggering this so that those injectors are going to be firing right on dead center.
Yeah. When we hook up the distributor, all we're going to do is hook this up right here, and we'll get the same response from the pulse width right here that we have. And see, I can adjust the pulse width by either going in a manual mode or in automatic mode. And in this case, I can go, you notice how I can adjust the injector. See how the pulse is going smaller and then larger?
Yeah.
I'll bring it over here, you can see it. There it is going smaller and then larger. And that's controlling the inject time of the gas going into the engine.
I really like those pulses because they're very, very clean. They're very sharp. That means our computer, our men's-writer computer, is going to be very, very good in our...
oh yeah, the signals are really good. They're nice and clean, and there's no problem. You see, as long as this switches up to high and low at a very sharp rise time and fall time, you're not dissipating any energy. Basically, all the electronics either turns on or turns off. So power-wise, this is the most efficient because it is digital. It's not sending as an analog device. Let's hook up the distributor and just rotate the engine because I want to see what it looks like with the same pulse. Just testing to see if all the injectors are firing, and they are firing. I'm actually turning it manually to watch it fire. Okay, and you can see right here. This one has an injector. That has an injector. That has. Now I'm going to turn it the way the car normally runs. Okay. So I got an injector here. Here, 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 and here. Okay? They're just come in the field of view right here. There. Saw it?
Mm-hmm.
That'll come in one more time. Getting ready to now.
Boy, that optics on the laser distributor is really beautiful, isn't it?
Oh, yeah. There. What I wanted to show you was we have the injectors here, which is connected to the electronics. The new module that we have right here is the cell driver itself, and this is the high voltage intensifier circuit that is being interfaced to the water cell itself. And essentially what we're doing here is that we are controlling the energy going into the cell. You will notice here that the pulses are changing the number of pulses that the cell is using to determine its power. You'll notice that there's a pulse train that is fed into the cell, and that is directly related to energy. And as I decrease the accelerator, I can decrease the number of pulses that the system sees. Up here, this particular signal is the signal that's fed into the injectors. If you listen to the injectors, You will hear and see that this pulse width gets larger and larger. And what this pulse is, you notice as I'm decreasing it, would decrease the injector time. And the clicking that you hear is the physical injector turning on and off. If you want to listen to all the injectors, that was all four of the injectors firing at a synchronous rate. Now, one of the features about the new power cell is that driver for the cell, which we call the driver and then the intensifier circuit, is that we can control the energy that goes directly into the cell. And we can pick out a point. We have an amplitude control. That would be where the signal adjusts in the amplitude. And then we can control the pulse train that's being fed to the cell so that we can precisely control the energy into the cell based upon the needs of the running of the car. In other words, you'll notice that the injector pulse, note here that the injector pulse is increasing in size, and we can determine the number of pulses that the system will be using for the cell, as well as lower the amplitude of the pulse, which now says we can precisely provide enough energy to the cell to give us enough gas to run the automobile. So it's very efficient in the respect that we're putting in very little energy into the cell to produce enough gas to operate the automobile. In the case of a manual setup, we can also adjust the system manually so that we can determine the frequency that's fed into the cell. Here you see that the injectors are running. This would be about 110, 115 miles an hour. And that's just one injector. If we turn on the rest of them, I don't think I want to be in a car when it's running that fast. It's a little bit too fast for my blood. All right, but the case in point that we want to make out is that the signal that's going into the cell, this here, we can control its energy. We can control the amplitude of the signal going into the cell, as well as control the number of pulses or pulse train into the cell. We have You'll notice here that I've changed to show you here that we are setting in a burst of energy into the cell where we're having a pulse train. They're gated on for several pulses and then off. The off time represents the time that the cell would be off. This would represent the energy. And as we do our adjustments to the system, you can actually see that the pulse train is actually decreasing, which would represent an energy decrease in the cell at this particular point. You'll notice that we can adjust it so that we have one pulse going into the cell for a given period of time. So as we increase our demands on the cell as needed, we can adjust this pulse train to give us the energy into the cell. This would be an example all the way out to just about full. That would be full 100%. This would start to reduce back to 10%. Now the interesting thing about the pulse trains are, again, if I adjust the amplitude of the system, you'll notice that the amplitude also decreases. So I can control the frequency of the pulse and the amplitude of the pulse train going into the water cell. Here again, this pulse over here represents the injectors firing at their rate. In this case, the car would be running in an idling condition. So this is what it would sound like if it was idling. This is what it would sound like if we were running about 60 miles an hour. You can see here again that This would be like 60 miles an hour. This would be your pulse tree, and you can see that I can control the amplitude of the energy going into the cell by the pulse train. You can see as I adjust this, you can see the pulse trains that are fed into the cell. So essentially what we've done is we've taken electronics now, gone from the accelerator itself into the accelerator card. That now comes over to the voltage intensifier.
Now this is working out pretty good though. That's pretty stable. Yeah, it's just a logo like this. Yeah. That's all. Okay. That's off with the oil come on, but okay, so now what we're going to do is go for the VIT unit, which we'll put in here. We'll set the VIT unit here. Yeah, all right.
Now, one thing about Jared Management is that's through the feedback.
Yeah, as far as the exhaust. Because it'll balance it out. You know, when you pull the exhaust out of here, it'll balance out the system. And then we can be able to adjust the burn rate to the engine will
Action.
Yeah, okay. All right, now, if I can go ahead and adjust this.
Yeah.
See, when we loosen this up,
Yeah.
I'll pull it back to there. Okay. 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 All right, let me help you on this then. Pull that out then.
Yeah.
Okay, I'll go get it right. Is this loose now? Is this one loose? Oh, it's not. What? Is that second one loose?
You think you can get one of those things to put on there so we can adjust it right underneath?
I think that's the way. So we don't have too much room between the hose here and here. It has to be a very short one.
Yeah. Oh, we can. We have to screw it tight
Yes.
when we roll.
Yeah. Okay. Let's see what we got here. Oh, I'll tell you what. Yeah. You down here, just put on that button. Sure. Let's see what.
This is the clutch right there. Now it's in top position.
What we have to do is just take the dope off and come back and say,
Yeah.
and turn around and smile at me. Okay, now so this is the kill switch over here. That's when you want to kill the whole system. Put this one right here. All right, so now the rest of it sits up. And this
The one way to calibrate this way.
we need to for emergency shut-off position.
This is going to go to the gas, like the wire.
Today is a VIC unit. This is the VIC cabinet itself. And you'll notice that the way this is designed is that we have the channels that plug in. And we have up to 11 channels that plug into the VIC unit. Now the power and the control signals are controlled by this panel over here on the right. We have an on-off switch, and this is the jack that controls the gating signal from the GMS unit that goes into each of these channels itself. And then this connector itself goes off to the water fuel cell. The main power from the batteries is connected here at this location. The unit that you see here in front of me is one of the cards that we're just now currently testing. We're just about ready to complete our testing on this card. What we're doing right now is turning the card on, and we've been testing each part of the circuitry to make sure that it performs to our requirements. One of the things that we are doing during the testing of the cards is we have a system in here. If you can hear the frequency and look at the oscilloscope, you will see that we have a scanning frequency. What happens is we are scanning the water fuel cell so that we can find a resonance point at which the system will lock onto. Now, under normal operation, with the cell being attached to the VIC unit, we would do the scanning. You'll notice that this level is going down, then back up, down, then back up. You'll notice that the frequency is getting higher and lower, and then goes back up high again. And that's actually, we're scanning the water cell, and when we hit the right point, it will lock on and maintain that level. Now what you see on the cards here is that we have a blinking light, which is the oscillator on. That tells us that we're actually controlling the frequency is being produced. We have a cell on light that would indicate that the cell is actually on and performing its function. And then we also have a lock light so that when it does capture that resonant frequency, the light will be on, indicating that we're locked on the water cell, we're in resonant, and we're producing the gas. You'll notice the switches here across the top. We have the capabilities of turning the unit completely on or completely off, or turn each individual cell on and off. And typically on the automobile, we're forecasting that we're going to use maybe this component right here. We're going to solder this component into the circuit right here.
Now when we're finished with the card, take the card, plug it into the heatsink like this. When that is plugged in like that, okay? Then that will be able to test this card out. So let's go ahead and solder this component right into that resistor.
All right.
Yeah. Okay, now this component that you just soldered, okay, in here will set up the frequency for this heatsink. Now we're all set with this card. We can now plug this card into the VIC unit. You clean up the wiring of this thing, you know, use your tool, and you can move these wires in the right spot, okay? Okay, well, you take the unit, that VIC card that we had right here that we were testing, put all those cards in there, and then you put the heat sinks in the back. And then what you do is put the unit in like this. Alright. In, and all you have to do is take the cap, put the cap on like that, put these 3 screws in, we got it. Okay. See that? Like that? Put it like right here like this. You know, it comes off like this. You can put it over like that. This exposes the channels, and this makes it look really nice. Now, these switches are the ones that we turn power on, so I can turn this cell on. There, I turn these 4 cells on, the rest of these cells are off. All the other switches will give me the... This is itself. I think it looks like a nice unit. It's mounted very rigidly and strong, and it... Turn this power on here, okay? Now, you do your reset it here, and now the water fuel cell is running and oscillating, okay? You go to manual mode or automatic mode. Now this cable, the VIC, is connected here, see, and it comes right up to this point right here. So when this unit's on, and you wire it to generate the gas from the water. When you turn this unit on, okay, each one of these, whatever's turned on, will start to scan and lock in at its residency, and each one of those things will produce the gas. This light, when it says cell on, means that cell's producing energy. Now the pressure will build up a little bit, and we'll start putting the gas right into the motor itself. Moving the cell voltage, causing this unit to turn on.
And basically how the water tank is going to work in conjunction with the resident cavity is the water now is going out into the resident cavity, then the gases is now acting as a water pump, which causes the water to go out of the resident cavity now into this filtering tray, which separates the contaminants and then allows the water to go back into the resident cavity during gas.
Take your cursor down to the diagram that you wanted to work with, okay? Open it up, all right? Then that'll display your